Percent error is actually an equation we're going to use quite a bit in the chemistry lab. For your percent error, you're trying to figure out how much error you actually created in the lab setting. It's very typical to have a little bit of error because we're humans and we make common mistakes. Typically though, in a lab, you're looking around, less than 15 or so percent error because you want to be as close to the correct value as possible. So in order to do that, we have a math equation that we will need to look at. I put the equation that's in your notes up here. So you have this A, this is your accepted value. Your accepted value is what everybody in the world tells you you should get. So let's say that you have the density of water. Density of water is 1 gram per centimeter cubed, so the accepted value would be 1 gram per centimeter cubed. The E is the experimental. For your experimental value, that's the data that you actually pull from the lab. So if you go through a lab and you actually get an experimental value of 2.6 grams per centimeter cubed for the density of water, you're going to have a lot of error in that lab. So the accepted is what everybody said you should get for an answer. Experimental is what you actually get in the lab. Now notice these little bars here. These little bars here are your value just saying, hey, this is an absolute value. Your answer here is always going to be positive. You'll never have negative error. So if we look at a problem, and I just pulled the one from the note packet, this is on the back. It says Dr. Gable was in the lab measuring the density of water. The answer that she got was 1.34 grams per centimeter cubed. The lab paper told her she should get 1 gram per centimeter cubed. What is her percent error? So we're going to look at the problem, and it says that my accepted value is 1 gram per centimeter cubed. In the experiment, Dr. Gable, which is me, got 1.34 grams per centimeters cubed. So looking at those two values, what we're going to do is we're going to set them up, and as we set them up, we have the equation that we're going to plug them in. So my accepted value, 1.00, minus my experimental value, 1.34. You're going to get an answer there. You're going to put that over your accepted value, which is 1 gram per centimeter cubed. So when I do this, I'm going to take my calculator, and when I take my calculator, 1 minus 1.34, you get negative 0.34 on top, divided by 1. This is going to magically disappear because of the absolute value sign, so you actually end up with 0.34 over 1. When you put this in your calculator, which some of you might not even have to do, 0.34 divided by 1, you get 0.34 times 100 to give you your percentage. My percent error was 34%. With percent error, you're looking at having 0% error. That would be a very perfect lab. This one's 34%. That's not so great. Your percent error could be more than 100%, but that's fairly rare. That means that you really did something wrong in the lab. So let's look at another problem, and we'll look at one from your homework packet. In your homework packet, it says that the literature value of the atomic mass of an isotope of nickel is 57.9 grams per mole. If a laboratory experimenter determines the mass to be 59.6 grams per mole, what is the percent error? So it's telling you that the book, the literature value, tells you that you should have 57.9 grams per mole. So in a perfect world, that's the answer that you should get. That's going to be my accepted value. So 57.9. They actually got 59.6 grams per mole. So I'm going to get an answer there. I divided by my accepted value, so what the literature says that I should get, 57.9. So I'm going to do the problem on top first, plug it into my calculator, 57.9 minus 59.6. I got negative 1.7. However, with my negative 1.7, that negative sign is going to disappear. So I just have 1.7 divided by 57.9. So I get 0.02936, and it can go on and on and on from there. Times 100, so I'm just going to take my calculator and just hit times 100. Round to 2 decimal places for it now until we learn about significant digits. So we have 2.94% error. We want to check our answer. I have the answers at the bottom, 2.94% error. So that is the correct answer.